Okay, so we're going to talk about exponential growth and decay. We have a times b to the x as our normal exponential function. A is the initial value, b is the base. For exponential growth, that b changes to 1 plus r. We think about it to the t, and 1 minus r to the t. T is the time in designated units. R is the rate of growth or decay as a decimal, not a percentage. To find r, use b minus 1. If the result is positive, you have growth. If it's negative, you have decay. All right, so let's look at it. Local coffee shop earns $150,000 in revenue during its first year. The owner expects the revenue to grow by 6% each year and the brand becomes more popular. What will the annual revenue be after 8 years rounded to the nearest dollar? So is this growth or decay? It tells us growing by 6%, so growth. So let's identify, we're going to use a times 1 plus r to the t. So we're going to identify a, r, and t. So A is our initial investment, $150,000. R is our rate, 6% as a decimal, so it's 0.06. And T is our time, 8 years. Just plug that into the formula, throw that in your calculator, you'll get around $239,077. Okay, have you try the next one? Pause it here, work this out, and come back and check your answers. Okay, so we see growth here again. It's increasing. So we're using the plus. So we're going to identify A and R and T. A is 450. Our rate is 12%, so it's 0.12, and the time is 10 years. Plug that in. We get about 1,398 turtles. Okay, try this one again. Now we're decreasing. So you're going to use 1 minus r. So try this one out, plug it in, come back and check your answers. Okay, A is 65,000, R is 0.15, T is 6, and you get $24,515. Try one more. Work this one out, come back and check your answers. All right, so this one is also decay because it's decreasing. So we're using 1 minus r. A is 120. R is 11%, so 0.11. T is going to be 5 hours. Plug all that in. We should have 67 milligrams left. Okay, now we're going to talk about compounding interest. I'm sorry, we got to talk about this. If they're growth or decay, then determine the percentage of rate or increase or decrease. So we do B minus 1. B is 1.045. Subtract 1, we get 0.045. So it's positive, so that's growth. And we're growing, move the decimal over 2 places, 4.5%. Here I do B minus 1. I get 0.87 minus 1 equals negative 0.13. So that's decay. With the decimal over it, we are decaying by 13%. So here, same thing. 7 over 2 minus 1 is 2.5. That's positive, so it's growth. This one's weird. You move the decimal over twice, and we get 250%. Same thing, 3 over 4 minus 1 now is negative 0.25, so that is decay. We are decreasing by 25%. Okay, so now let's talk about compounding interest. The formula for compounding interest. Compounding interest essentially means, so I get $10,000 with an annual interest rate of 4%. If it's compounded quarterly, which means 4 times a year, how much money will we get in the account after 5 years to the nearest cent? So normally, if we didn't have the compounding, we'd just say 10,000 times 1 plus 0.04 to the 5th power, and we'd get some number that I don't know offhand. 10,000 times 1.04 to the fifth. We get about 12,000. Matter of fact, let's do this. Let's make this easier on ourselves. We'll call it 1 year. Well, after 1 year, I would have $10,400. Now what's going to happen is it compounds quarterly. So this would be like Jan 1 of 1 year, January 1 of the next year. You'd have that. If it compounds quarterly, you would have this, you put it in this January 1st. And what we do is this is going to happen. I should have written that. You're going to take the interest rate and divide it by the number of times it's going to compound. And you're going to get 1%. So what I'm going to get is 1%. So I'm going to get $10,100, but I'm going to get that on what? January, February, March, on April 1st, after 3 months. I get that today. Then, April 1st, now you're getting $10,100. And we get whatever that is, and whatever that is, we'd get here on April, after 3 more months, April, May, June. So in July 1st, we'd get whatever this number is. 1 plus 0.01. We get that, and then we know what we do in this 4 times is the idea. We do it 2 more times. You get a quarter of your interest every 3 months, 4 times throughout the year. So you're getting interest on top of interest. A little hard to explain, but there's a nice, easy formula for it. And that is this, where A is the amount you end up with at the end of the whole thing. P is the principal, the initial investment. R is the rate as a decimal. N is the number of time it compounds per year, and T is the time generally in years. So now let's do this way. $10,000 if we didn't compound. We'd get, I just threw it in my calculator, 12,166.52. Let's write that. No compound, 12,166.52. So let's see what it comes out if we do compound it quarterly. Oops. 166.52. Actually, it's 5.3, round. Okay. So the principal is $10,000. The rate is 4%. N is 4. T is 5. Throw that into the calculator. And you're going to get $12,201.90. So we get a little bit more by compounding it. You're getting interest on top of interest. You cut the interest rate. You take that 4% interest and divide it by 4, and you get that 4 times a year. But you get it on what's in there. So it's like you get, after you add the 1%, well, now you get a 1% of that. Then you get another 1% of that new thing and that new thing, just like compound, just like interest year to year. Okay, let's try it. Have you tried both of these and see what you get? Pause it here, work these out, and come back and check your answers. Okay, principal is 2,500. The rate is 0.18. N is 12, T is 2. So that credit card that you ran up $2,500 on after 2 years is going to come out to $3,573.76. So you invest $5,000 in a corporate bond that pays 5.5 interest. Semi-annually, that means twice. I should have mentioned that. Semi-annually means twice. N equals 2. What will the investment be worth after 10 years to the nearest cent? Okay, plug all that in, and we get $8,602.14. Okay, we have a new thing now we have to do. Let's get daring with our investment. We find a bank that is willing to offer an interest rate of 100%. So we're going to invest $1. If it compounds annually, how much we have after a year. So if I put in $1 and I get 100% interest after a year, I'm going to have $2. That's kind of the point. I would get 100%. Now, semi-annually, think about it. Jan 1, I put in $1. So on June 1, I would get $1 plus 50% of $1. I get half of my interest, half of my 100% interest I'd get on June 1st. So I'd get $1.50. January 1st of the next year, I'm taking this $1.50 and adding half of $1.50. So now I'm going to end up with 2.25. So if I compounded twice, I'm going to get with $2.25. So what would happen if I did it quarterly? And notice this one went away. Well, so is this one. You're just doing the inside part over the number of time it compounds to the number of time it compounds. So throw that in the calculator and see what you get. Then do monthly, weekly, daily, and see if you can do every minute. Okay, quarterly, we're gonna get about $2.44 after a year. Monthly, I'm gonna get about $2.61. We did a pretty good jump there. I changed weekly, 52 days or 52 weeks, 2.69, only went up 8 cents. Now let's change this to 365 and only go up 2 cents. I say this every year. I hope somebody in the room knows how many minutes there are in a year and can sing it. There's 525,600 minutes in a year. And so that only gets us to $2.72. What I would love for you to do right now is go into Desmos and just put the letter E in Desmos, and you'll get 2.718 something, 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 about 2.72. As this number, this big number here just gets larger and larger, we cap out at this thing. And it's the number is just called E. This is if it compounds infinitely many times over the course of 1 year, of 1 unit of time. So you're dividing the interest rate infinitely and then getting that much interest infinitely many times throughout a year. So that's used if the rate is compound continuously. And so we have a new formula for continuously compounding interest is A equals P times E to the RT. So we put it to use. A biologist studied a bacteria culture that starts with 500 cells. The colony grows continuously at a rate of 15% per hour. How many bacteria will be present after 24 hours to the nearest whole number? So A is 500, R is 0.15, T is 24. You just literally throw that in the calculator. And you get about 18,299 bacteria. Okay, you're going to do these two, pause here, work these out, and come back and check your answers. Okay, so 8,000.065 and 12, and we get $17,451.78. So pretty good. You doubled your money in 12 years. Hopefully you're putting more money into that account as you go, and it'll even help there. GDP of a developing nation is $45 billion, is expanding continuously at a rate of 3.2% per year. What will the GDP be in 10 years? The nearest tenth of a billion. So we start with 45.032, 10, and we get right at $62 billion. All right, that is it for exponential growth and decay. Good luck.